I'm Nova.
I'm Alloy, and this is AgentStack Daily.
MiniMax has released an open-weights music model that can turn tagged lyrics and a track description into a complete 5-minute stereo song in one pass. No stitching short clips together and hoping the chorus still sounds related to the verse.
Okay, that's actually wild. Google has also open-sourced a zero-trust mesh for agents sharing tools across clouds, private networks, laptops, and edge devices. One agent can reach another agent's approved tools without forcing the underlying service onto the public internet.
Today, full-length music generation from MiniMax, Google's sovereign agent mesh, Cerebra's moving wafer-scale inference into a rack, and CUDA agent teaching language models to write faster GPU kernels.
You'll hear how OpenAI wants to combine zero data retention with private safety checks, why enterprises are routing each request to a different model, and what happened when cooperating agents planned a campus wireless network better than one agent working alone.
Plus Hermes Desktop has bot mode, Replit is opening free software building through GPT 5.6 Luna, and GitHub is giving enterprises tighter control over Copilot inside JetBrains. OpenAI has reaffirmed zero data retention for eligible API customers and previewed private safety processing, an option meant to apply advanced safety checks without retaining the customer's underlying content. That combination matters because privacy and safety can pull an enterprise workflow in opposite directions. A bank, hospital, or government agency may require strong screening for harmful model behavior, yet refuse to send sensitive prompts and outputs through a system that keeps them for later inspection. Zero data retention preserves the commitment that eligible API data isn't retained after processing. OpenAI says the private safety approach will perform evaluation inside a hardened environment and discard the input and output after the check finishes. In plain English, inspect the request, enforce the safety control, then avoid creating another lasting copy. OpenAI positioned the preview as a response to regulated customers that want frontier model safeguards without surrendering data sovereignty. Pricing, access requirements, and availability are expected next month, so the established retention commitment is firmer than the previewed layer.
That's a real tension to tackle, but I don't buy the idea that a preview has solved it. Customers still need precise answers about which safety checks run, whether flagged material follows a different path, who can use the service, and what evidence supports compliance claims. Even so, the direction is important. A healthcare assistant could screen generated guidance while keeping patient material ephemeral. A financial institution could apply output controls to an internal analysis workflow without building a permanent trust and safety archive. Government teams could keep sensitive requests within a tightly defined data flow. OpenAI's proposal treats privacy-preserving safety as infrastructure instead of asking customers to choose one promise over the other. If the hardened environment and deletion guarantees arrive with useful technical documentation, projects stuck between compliance and safety teams may finally have a path forward. Google's sovereign agent mesh sounds ambitious, agents calling tools across organizational and network boundaries without public endpoints. How does it avoid becoming an elaborate new hole in the firewall?
By starting from denial rather than connectivity. Google has open-sourced SAM under the Apache 2 license as a peer-to-peer overlay for agents operating across cloud systems, on-premises infrastructure, laptops, and edge devices. Identity begins with OpenID Connect, the login standard already used by many corporate identity providers. SAM then issues Biscuit capability tokens. Those are compact credentials that state exactly what a node may do, such as invoking one named tool, rather than granting broad access to an entire service. Each participating node verifies the token locally, so every request doesn't need a round trip to a central authorization server. If no valid credential explicitly grants the action, the tool call is denied. That lets a laptop agent invoke an approved cloud capability, or an on-premises agent reach a tool on an edge device, without publishing the service to the open internet.
Now that's more interesting than another agent discovery layer. MCP compatibility means tools exposed through the Model Context Protocol can be discoverable through the mesh, while the capability token constrains what a remote agent can invoke. The hard part arrives when organizations rotate identities, revoke access, audit long chains of calls, and connect nodes owned by different security teams. Local token verification removes a central dependency from every request, but it makes disciplined credential policy essential. Still, SAM addresses an urgent problem: useful agents rarely live inside one tidy network. If the project gains adoption beyond Google's ecosystem, it could give cross-company agent collaboration a security model that doesn't begin with, "Please expose another API."
Cognition's chief executive has denied a report that SpaceX was in early talks to acquire the AI coding company. The original report appeared on August 19, but there's no on-record confirmation from SpaceX and no disclosed price, timeline, or deal structure. The denial is the concrete news; everything beyond it remains uncertain. The market context is still notable. SpaceX has already acquired Cursor and is pursuing a larger position in enterprise AI. Another reported approach to a coding-focused company would fit an aggressive consolidation strategy, though strategic fit isn't evidence that a negotiation happened. Cognition has built its identity around autonomous software work, while Cursor occupies the competitive AI-assisted coding environment. Owning both could create a broad development stack, but that's hypothetical until either company supplies more than a disputed report.
Rumors can reveal something without proving the transaction. Investors and acquirers see AI coding products as strategic assets, not disposable interface layers over interchangeable models. Talent, user distribution, proprietary interaction data, and deep integration into development work all have value. A rumored combination also raises questions about product overlap and independence. Would Cognition remain distinct? Would its autonomous approach be folded into Cursor? Would customers want two coding products controlled by the same parent? None has an answer because there's no confirmed deal.
Honestly, I'd go one step more skeptical. People often treat acquisition reporting as a product roadmap written in advance. It isn't. Early conversations can end, valuations can fail, and parties can disagree over whether exploratory contact deserves to be called talks. Cognition's public denial deserves more weight than an imagined integration diagram.
Fair. What survives either outcome is the category-level pressure. Well-capitalized companies want ownership of interfaces where developers increasingly delegate work to agents. Even if Cognition stays independent, the report highlights which coding startups have durable technology and distribution, and which could become acquisition targets as the market compresses. Arvind Jain, Glean's chief executive, argues that enterprises are moving away from one default model for every request. Is routing really a major product capability, or just a cheaper model selected by an estate?
Static routing can be that crude, but Jain described a richer feedback loop. Easy questions can go to a faster, less expensive model, while difficult requests justify a frontier system. The routing layer learns from large-scale human feedback about which answers were helpful, then uses that signal when a similar request arrives. That turns allocation into an ongoing product decision rather than a fixed engineering rule. The economics are straightforward. A company may have thousands of routine retrieval, summarization, classification, and drafting requests that don't benefit enough from the most expensive model to justify its price. The same company has complex analytical or agentic work where the stronger model materially improves the result. Routing per query lets both coexist without paying the highest rate for everything.
I buy the economics. I'm less convinced that helpful always maps cleanly onto the best routing choice. Human feedback can reflect preference, speed, tone, or familiarity rather than factual quality. A router that saves money also becomes a gatekeeper. It decides which employees and tasks receive the strongest reasoning. Administrators will want visibility, especially when a cheap model produces an acceptable-looking answer that misses an important detail.
Exactly. The router can't remain invisible plumbing once it influences cost, latency, and answer quality across a company. Glean's argument matters because enterprises already pay for a mixture of frontier and open-weight models. Competition won't only concern which provider has the strongest model, but who recognizes when that strength is worth buying. A good routing product turns a diverse model portfolio into controlled spending. A bad one hides quality reductions behind a lower invoice. MiniMax has released MiniMax Music 3, an open-weights text-to-music model that generates a complete song lasting up to 5 minutes in a single pass. It accepts lyrics marked with section labels, verse, chorus, bridge, and a structured caption describing the desired track. The result is a 32 kHz, 16-bit stereo WAV file. That full-length generation is the headline. Earlier open music systems often worked in shorter clips, leaving creators to extend, regenerate, or stitch sections together. Every seam could disrupt the melody, instrumentation, pacing, or vocal identity. MiniMax is attempting to hold the song's structure across the length of an actual commercial track. It also provides 3 serving paths, allowing the weights to be used through different local or remote deployment arrangements. The license terms still govern commercial use. Open weights means the parameters are available, not that every use is automatically unrestricted.
5 minutes in one pass is genuinely exciting because it changes the unit of creation. A game studio can draft a complete vocal track for a scene. A podcast producer can request a full theme variation instead of looping a 30-second fragment. A video creator can start with tagged lyrics and receive something shaped like a finished song, with an intro, repeated chorus, bridge, and ending. The output may still need editing, mixing, or human performance decisions, but the first result is no longer merely a musical sample. It's a composition-length object that can be judged as a whole. I want to know whether it preserves motifs and vocal character across all 5 minutes, because duration alone doesn't guarantee coherence. But single-pass structure removes one of the most obvious mechanical limitations from open music generation.
Cerebras has introduced the CS4, its first rack-scale AI inference system, paired with a refreshed WSE3 turbo processor. The company is moving beyond wafer-scale computing as a single unusual appliance and presenting it as infrastructure for a data center rack. Instead of cutting a silicon wafer into many conventional chips, Cerebras uses an enormous connected processor intended to keep computation and memory movement close together. The CS4 extends that approach into a larger deployment surface for inference, the work of running an already trained model. The announcement drew attention from hardware specialists, including hundreds of votes in the technical community, because inference capacity is becoming a defining AI infrastructure constraint.
A rack is language data center buyers understand. They compare power, cooling, throughput, space, networking, serviceability, and price across complete systems. Cerebras is signaling that its wafer-scale design belongs beside established accelerator clusters, not in a category of experimental machines. That could matter for organizations serving large models on their own infrastructure, particularly if it reduces the complexity of dividing one workload across many processors.
Yes, but the missing numbers are doing a lot of work. Cerebras hasn't published the detailed throughput, pricing, or broader specifications needed for serious comparison. Rack scale tells us packaging and ambition, it doesn't reveal cost per generated token, realistic concurrency performance, energy efficiency, or behavior across model sizes. The WSE3 turbo name tells us there's a refreshed processor, but a reveal without a full datasheet isn't a measured victory over GPU clusters. Still, AI infrastructure buyers need credible alternatives as inference demand grows, and wafer-scale hardware offers a materially different design. Once performance and price arrive, the CS4 can be judged against established systems. Until then, Cerebras has advanced the conversation without settling it.
Spade lets one language model create executable practice environments and learn by solving them. Isn't there a danger that a model writing both problems and answers simply becomes good at its own game?
That's the central challenge. As environment designer, the model creates puzzles, simulations, or tool use tasks with built-in scoring. As reasoning agent, it attempts them. The designer aims near the solver's current ability, difficult enough to teach, but not impossible.
Here's why it gets interesting. It also grounds new environments in real documents from a large pre-training corpus and remembers earlier creations to reduce repetition. At scales reaching 30 billion parameters, the researchers report an average gain of 5.3 points over the strongest fixed environment baseline across 8 held-out math, science, coding, and reasoning benchmarks.
The held-out gains make it interesting. Improvement also appeared in multi-step tool use, so the result wasn't confined to replaying self-authored puzzles. If reproduced, agents could generate useful practice near their own frontier instead of waiting for people to design every training environment. Nous Research has shipped bot mode for Hermes Agent, and it's enabled by default in Hermes Desktop. The desktop now presents a roster of named bots instead of treating every interaction as another session in one undifferentiated list. Each bot is a complete Hermes profile with separate chat history, memory, skills, tools, and model configuration. The practical change is isolation. A coding bot can retain software context and relevant tools, a research bot can keep its own sources and working history, and a writing bot can preserve a different voice without those identities bleeding into one another. Hermes Agent remains open source under the MIT license, and bot mode is bundled with the desktop rather than distributed as a separate add-on. That makes multi-agent organization a default interface concept rather than an advanced configuration hidden behind files or commands.
I like the roster metaphor because people already think in roles. They don't necessarily want session 47, they want the bot that understands a particular kind of work. But the separation has to be real. If each profile carries its own memory and tools, the interface can reduce accidental context crossover and make capabilities easier to understand. A bot intended for writing shouldn't silently inherit access meant for software operations.
Right, and model configuration per bot is useful without promising that any remote model will remain permanently available. Providers can change access, and applications may substitute another model. The durable feature is that each profile can express its own model preference and capability bundle. That's different from guaranteeing permanent access to a named model. The release is strongest where it makes agent identity visible and switchable without requiring people to reconstruct an entire working environment. It also makes the active identity legible before a message is sent. That sounds small, but it matters when several agents have different histories and different access to tools.
And it creates an intriguing social possibility. If Newslater supports portable community profiles, people could exchange specialized bots with a useful skill set, memory structure, and tool configuration, closer to importing a working role than downloading a generic prompt. That hasn't been announced, so it stays a possibility. For now, Hermes Desktop has made multiple persistent agent identities much easier to manage, which is substantial enough without borrowing features from the future.
Researchers assigned cooperating AI agents the problem of placing millimeter-wave base stations across a campus, and the team outperformed a single agent controlling the whole map. Millimeter-wave wireless can deliver high capacity, but buildings and terrain obstruct it easily, making rooftop placement a difficult optimization problem. Each agent managed part of the geography while cooperating toward coverage and fairness. In dense simulations, the multi-agent approach converged faster, covered all 400 simulated users, and reached a fairness score of 0.94.
That's a strong result for distributed planning, not proof that every infrastructure problem needs a swarm. The campus map can be divided into meaningful regions, giving specialized agents manageable responsibilities. As density increased, cooperation handled the search better than one learner carrying the entire problem. Similar structures appear in stadiums, transit hubs, logistics networks, and energy systems, where local decisions interact but don't require one giant controller. The result gives those fields an early example of coordinated learners outperforming a solo optimizer on coverage and balance. Language models have become surprisingly competent at writing CUDA kernels, the small GPU programs behind many high-performance operations. Why do those generated kernels still disappoint experienced engineers?
Because working code and fast code are different achievements. ByteDance Seed and Tsinghua Air introduced CUDA Agent to train language models against runtime performance, not correctness alone. Their Seed 1.6 base model passes 74% of kernel bench problems, showing it can frequently produce valid CUDA. Yet valid output may use memory inefficiently, synchronize too often, launch unnecessary work, or fail to exploit the GPU's parallel hardware. CUDA Agent uses reinforcement learning. The agent generates a kernel, executes it, receives a reward tied to measured speed, and updates its behavior. Repetition teaches the model to pursue performance improvements ordinary code generation training may miss. Instead of rewarding text resembling expert CUDA or merely compiling and returning the right number, the process rewards code that completes the computation faster.
That observed result is the news. Custom kernels can decide whether a model training or inference system is economically viable, but engineers capable of hand-optimizing them are scarce. If a trained agent produces competitive kernels, it could shorten the path from a new operation in a paper to efficient execution on real hardware. I'm cautious about generalization because kernel bench isolates problems unlike production frameworks, where neighboring operations, launch overhead, compilation behavior, and hardware variation all matter. A benchmark can show that performance-directed learning changes generated code, it can't prove an entire training stack becomes faster. Still, CUDA agent attacks the right target, actual runtime instead of code that merely looks plausible.
Replit introduced free mode on August 19, allowing people to describe an idea and generate runnable software without first adding a credit card or tracking token charges. GPT 5.6 Luna powers the free experience, and OpenAI announced the collaboration through its own news channel. The audience includes students, first-time creators, and people exploring a small idea who might otherwise stop at the paywall. Replit turns a plain language request into a working project, keeping code generation, execution, and iteration in one browser-based environment. Removing the upfront payment decision changes who can reach the moment when an idea becomes interactive. A student can build a study tool, a community organizer can prototype a registration app, and a designer can make a utility without first purchasing capacity they may understand poorly.
Free is powerful, and it needs limits printed nearby. OpenAI's announcement doesn't spell out the usage allowance, which tasks qualify, or when someone must move to a paid plan. Those details determine whether free mode supports a meaningful project or mainly provides a compelling demonstration. Even with that uncertainty, opening the complete create and run loop is more consequential than offering a free chat box that emits code snippets.
Still, experienced developers may benefit too, though this doesn't replace a full professional environment. It provides a quick surface for trying a library, sketching an interface, or seeing how Luna approaches a small application. The outcome matters more than token accounting. Can the free user deploy or share something useful, and understand what was generated well enough to continue? I'm cautiously optimistic. Pairing Luna with a no-card starting point puts a capable coding experience before people who may never have opened an integrated development environment. Whether it becomes a broad entrance to software creation or a short runway into a paid plan will depend on the limits Replit hasn't detailed. GitHub has added enterprise-managed settings to Copilot for JetBrains, covering the development environments behind IntelliJ, PyCharm, Golang, and other widely used tools. Administrators can now apply organization-wide controls in 4 areas: plugin governance, MCP server access, OpenTelemetry, and permission modes. Plugin governance determines which extensions or capabilities are allowed. MCP controls determine which outside tool servers Copilot may connect to. OpenTelemetry standardizes the operational data collected and exported. Permission modes define which actions the assistant can take and when it must ask a person first. The change closes a governance gap for companies that wanted Copilot in JetBrains but couldn't rely on every developer configuring those controls consistently.
It's not glamorous, but honestly, changes like this can move adoption more than another clever coding demo. A company can have excellent model performance and still block deployment because the plugin reaches unsanctioned tools, emits telemetry under inconsistent settings, or asks every developer to interpret permissions differently.
And MCP access is the control I'd watch most closely. An ordinary code completion tool mostly suggests text. A tool-connected assistant may reach repositories, issue trackers, databases, cloud resources, or internal services. Central policy lets an enterprise define which servers are sanctioned before every developer builds a different trust boundary around the editor.
Exactly. Central settings turn Copilot from an individually configured assistant into managed enterprise software. Developers get consistent behavior across JetBrains products, while security teams gain a defined place to govern permissions and exported operational data. That's less exciting in a demo and much more useful during a real deployment.
OpenAI has added safeguards around model development following a breach at Hugging Face. Public reporting says the changes include more detailed monitoring during development and a stronger emphasis on alignment and security during post-training, the stage after initial model training when developers shape behavior, improve instruction following, and add safety controls. OpenAI hasn't publicly detailed exactly what the breach exposed or which internal threat scenario prompted each measure. That limits how specifically anyone can assess the response. What is clear is that an incident at an adjacent AI platform caused a frontier lab to tighten protection around its own model development pipeline. OpenAI says released models weren't affected, so this isn't an announced defect in the models or APIs people are currently using.
That distinction matters, and honestly, the surrounding supply chain still deserves attention. Labs depend on model repositories, datasets, development services, evaluation systems, credentials, and outside tooling. A compromise near the lab can expose artifacts or pathways that matter even when the final weights remain protected. We don't know the precise trigger, affected material, or whether the new monitoring changes any release schedule, so a dramatic breach narrative would outrun the facts. More detailed monitoring could reveal suspicious activity earlier, while stronger post-training security protects a particularly sensitive stage. OpenAI has acknowledged the cross-platform exposure and responded internally. The useful next disclosure would explain which controls changed and what outsiders can independently verify. VentureBeat has hired Rob Strechay as its first lead analyst and a founding member of VentureBeat Research. Why does a media company adding an analyst seat matter beside model and infrastructure news?
Because enterprise AI buyers increasingly need comparisons after the launch headline. Strechay joins from theCUBE Research and SiliconANGLE, where he served as managing director and principal analyst and conducted executive interviews. He previously worked at Enterprise Strategy Group and held operational roles in enterprise infrastructure, including work on an analytics service at Amazon Web Services and an executive position at Zerto. VentureBeat says the research group will serve directors, vice presidents, chief information officers, and chief technology officers evaluating and deploying AI. Its early subjects include multi-vendor orchestration, security inside agent systems, and poor infrastructure utilization, costly problems that appear when prototypes meet procurement, policy, and production traffic.
I'll reserve judgment until it publishes substantive work. Enterprise AI already has plenty of confident adjectives wrapped around survey charts. Still, the focus is timely. Companies are combining frontier models, open weights, cloud services, internal data, and specialized tools, while agent security stretches across identity, permissions, and tool access. Infrastructure utilization decides whether an accelerator fleet produces useful work or merely an impressive bill. Strecchay's operational and analyst background gives the group a credible starting point. Its value will depend on whether it connects deployment evidence to actual buying and operating decisions, rather than repackaging executive interviews as certainty.
3 repositories are moving fast. HCUD/Nanobot makes its first tracked appearance with 47,217 stars. Point 3 shipped July 25, and the project was updated August 20. It's an ultra-lightweight, self-hosted Python agent framework with a web interface, memory, tools, MCP connections, automation, chat apps, and multi-agent workflows. Deus Data/Codebase Memory MCP is close behind at 39,645 stars, up 7,978 in 30 days, a 25.2% jump. Point 10 arrived August 19. It indexes code into a persistent knowledge graph across 158 languages, enabling agents to query relationships without repeatedly loading entire repositories.
Okay, that pairing clicks. Nanobot supplies an agent environment, while Codebase Memory MCP can give an agent structured knowledge of the software it's changing. Prefect HQ/Fast completes the tool layer. It has 27,312 stars, gained 1,098 over 30 days, and shipped a 3.4 release on August 10. Its Python framework is designed for building MCP servers and clients, so developers can expose capabilities to tool-using agents with less protocol scaffolding. Nanobot has the largest audience of the three. Codebase Memory MCP has the sharpest growth. FastMP remains a widely adopted route for turning Python functions and services into agent tools.
Model progress landed in long context specialization rather than a distinct new general-purpose family. Z.Re's GLM 5.3 appeared with a 1,048,576 token context window and API access through OpenRouter, aimed at complex software engineering and long-horizon agent work. It extends the GLM family's push toward agents that can carry much larger bodies of code and working context through a long task.
Qwen/Qwen 3.8, 27b, written Qwen/Qwen 3.8-27b, is drawing heavy attention as an open local model, with 11,599 likes and more than 1.37 million downloads on Hugging Face. It handles image and text input with text output, supports conversational use, and ships in the SafeTensors weight format under the Apache 2 license. Compatibility tags include common transformers tooling, hosted endpoints, and Azure deployment. At 27 billion parameters, it sits above lightweight laptop models but below the largest data center systems, making it plausible for capable local workstations or servers with sufficient memory. The combination of visual input, open weights, broad runtime support, and substantial download activity makes it useful for private document, screenshot, and interface analysis where data should remain under local control.
OpenAI has introduced ChatGPT for teens, built for learning, backed by protections, with stronger built-in safeguards, healthy use features, and additional parental controls. IBM researches how much memory does your agent actually need examines the other side of responsible assistance, retaining enough history for continuity without dragging every old interaction into the next decision.
That connection is worth watching. One product places boundaries around who an assistant serves, while the memory work asks what an agent should carry forward. GitHub's enterprise-managed settings in GitHub Copilot for JetBrains adds organizational boundaries around MCP access, telemetry, plugins, and permission modes. Together, the three developments constrain the user relationship, the remembered context, and the outside tools an AI system can reach.
For the primary sources, specifications, project references, and further detail behind everything you heard, look at the show notes at tobyonfitnesstech.com.
Thanks for listening to AgentStack Daily.
We'll be back soon.